Okay, so in this section, I will review hemostasis, which is the process of blood clotting, so stopping bleeding. And there are three main stages that are involved. So after an injury, the first step would be a vascular spasm, followed by platelet plug formation, and then that's followed by coagulation, which involves the actual formation of the blood clot. So we will start with the vascular spasm. This is exactly what it sounds like. It's a spasm of a blood vessel, so constriction of a blood vessel immediately following an injury. So it's constricting, and that by doing that, it's reducing the flow of blood through that damaged vessel to hopefully reduce blood loss. And that can last for up to 30 minutes. It's not a permanent solution, but it's a temporary solution, which kind of allows some time for the platelet plug and then for the actual blood clot to form, which would hopefully be a permanent stop to blood loss. So after that vascular spasm, or actually sort of while the vascular spasm is happening, that's immediate. And then that is followed by platelet plug formation. This is basically the formation of just a big plug of platelets, like a big collection, a big group of platelets that kind of plug up the injured area in order to stop blood loss. So to understand how that's formed, you first sort of have to understand the conditions within a blood vessel when there's not an injury. So this picture is showing you the inside of a blood vessel that has not been damaged. So this is the lumen. This is the space that blood is passing through. And then these right here, 1, 2, 3, are the 3 layers of the blood vessel wall. This is the inner layer. This is just a thin layer of endothelium, which are epithelial cells. And then you have the other 2 layers on the outside. So these cells, these endothelial cells, secrete 2 chemicals. They secrete prostacyclin and nitric oxide. And these chemicals that are being released into the blood prevent platelets from sticking to each other and from sticking to the blood vessel wall. So it prevents, what it's saying here is it prevents platelet aggregation. That means like the grouping, the clumping of platelets in one spot. So that's going to keep the platelets just flowing through the blood, which is normal. But if there is an injury, that is going to change. So this is another picture of the blood vessel. Here's the lumen. You can see blood cells flowing through the blood. These yellow cells are the endothelial cells, and then the other layers of the blood vessel wall are on the outside. When the endothelium is damaged, the underlying layers underneath are now exposed. Normally, they're totally covered by the endothelium. But when that is damaged, like what happens when there's an injury, then collagen fibers that are in these deeper layers of the blood vessel wall, they are exposed. And these fibers, these collagen fibers, actually have a negative charge. These platelets, which are the small purple cells that you're seeing in the blood vessel lumen, these have a positive charge. And positive charges are attracted to negative charges. Opposites attract, right? So positive platelets are attracted to these negative collagen fibers. And that means that they start to stick to this area. You can see them sort of grouping together already. Then what happens is, you can see that a big group, they start to stick to each other. They stick to the collagen fibers that are here. They actually kind of change their shape a little bit. You can see that they extend projection. So they're kind of like reaching out and grabbing more platelets and pulling them into that big grouping right here. And another thing that's happening is that they are releasing chemicals. They're releasing chemical messengers that enhance the vascular spasm and that also attract even more platelets. So more are coming into that group and helping to sort of plug up that hole to prevent blood loss. So all of this is called platelet aggregation, when you have more and more and more platelets joining that initial group of platelets to form the platelet plug. Okay, so this is the resulting platelet plug. It is basically plugging up that opening that was here, which was the initial injury causing blood loss. So what's going to happen after that is blood clotting or coagulation. So this is the formation of an actual clot to reinforce the platelet plug. The clot actually forms sort of around and on top of the platelet plug. And the actual clot is formed by proteins. It's like a mesh network of protein that surrounds those platelets. The process involves clotting factors, which are produced by the liver. They normally circulate through the blood, but they're inactive. When they are activated, then these clotting factors turn into enzymes, and they basically activate each other. So one clotting factor gets activated and it activates the next one. And then that one activates the next one, and it keeps going and going. So you have all these activated clotting factors now that trigger blood clotting. So either clotting pathway that is followed, there's intrinsic and extrinsic. They're described in the web page that I created on D2L, but I'll go over each quickly here. But no matter which one you follow, clotting ends the same way with the same, it's called the common clotting pathway. So there's an intrinsic and an extrinsic pathway. With the intrinsic pathway, that's generally the result of like a really minor injury to a blood vessel wall. And it occurs exactly the way that I just described. When you have an injury to the blood vessel wall, the negative collagen fibers are exposed now, and platelets, which are positively charged, are attracted to the negatively charged collagen fibers. They form the platelet plug, and that's how that process works. It's a little bit slower than the extrinsic pathway because it involves more steps. The extrinsic pathway is usually the result of a larger injury to a tissue or a group of tissues even. And it's triggered when the injured tissue releases a chemical called tissue factor. So that's released into the blood, and it triggers the extrinsic pathway. This is a quicker pathway because it involves less steps. So either way, whichever type of injury that occurs, whichever pathway is followed, no matter what, both pathways form a chemical called prothrombin activator. And that's listed right here on the PowerPoint. So then prothrombin activator, and this is going to happen no matter what type of injury you had, it converts the plasma protein prothrombin, it's a protein that is always found in your blood, but normally it's just inactive. So now this activates it. It does exactly what the name says. It's prothrombin activator. It activates prothrombin. So it converts prothrombin into thrombin. That is its active form. Then thrombin converts fibrinogen, which is another plasma protein that is inactive. It's normally found in the blood, but thrombin is going to convert fibrinogen into fibrin. And fibrin is actually the protein that forms the blood clot. So once fibrin is activated, it acts like a glue to kind of hold the platelets that have aggregated in that one spot together. It also will trap potentially other blood cells that are passing through. It'll trap them in the clot as well. That's normal. But fibrin is the protein that actually forms the blood clot. And here's a picture under the microscope of what a blood clot looks like. So You can see the early stages and then the late stage blood clot. The green things that you're looking at, these are the platelets that are in that big group of platelets that originally formed. And the red fibers here, that's fibrin. Okay, so that's the protein that actually forms the clot. Here you can see that much more fibrin has formed. So that is the common clotting pathway from when prothrombin activator activates prothrombin all the way to the time that fibrin is formed, and then the fibrin forms the actual blood clot.